What's up, Algebra 1 folk? Today we're talking about independent and dependent events, and we're going to find the difference between the two and how are we going to calculate them. The calculation part's going to be really easy. But distinguishing between the two, we might have some issues. Basically think independent means you don't depend on anybody. Your parents don't buy you food, you don't live under their house, you're completely independent from them, versus dependent where you might need to depend on them for food, clothes, yada yada yada. So we talk independent events in probability. It's when two or more events occur, and then we have one event does not affect the outcome of another event or other events. So think of rolling a die. You roll one die, you get a 5. Then you roll the next die, you roll a 3. You keep rolling a die. The outcome of the one roll doesn't affect the outcome of the other roll. You still have a 1 out of 6 chance of those numbers happening. When we go down to dependent events, it's when two or more events occur, and the first event has an outcome or affects the outcome of the second event, might affect the outcome of the third event, and so on. So think of dealing cards. I deal out one card. I went from 52 cards to 51 cards. Now I have 51, take one away, 50, you deal another card out. So the probability and the numbers are always changing. That means the events that will occur in those situations would be considered dependent events. So before we get into the calculation, let's just quickly review OR statements. When we have a spinner, it's shown here and it has 12 equal size sections. We want to find the probability of a 2 or a 5. And I am going to underline that keyword of OR, because that's going to tell us if we're going to add like we were the other day or if we're going to go through and multiply. So the probability of a 2 or a 5, well, we look up here, there's 1 2 and there's 1 5. So there's one outcome apiece. We add those together, you get 2 over 12, or it reduces down to 1/6. You go through and do a multiple of 2 or 5 now. And you would go through 2 or 5, I should say. So the multiples of 2 are, and I'll put little dots on the outside for this one, we have 2, 4, 6, 8, 10, 12. There's 6 multiples of 2. How many multiples of 10 are there? Well, there's 5 and there's 10. So there's 2 multiples of 5. Now our problem is we just counted out 10 twice because it's a multiple of 2 and 5, so we're going to subtract that out. We have 6 plus 2 is 8 minus 1 is 7. Our probability is 7 out of 12. You would do the same kind of concept, so you can try the last one here quick on your own. It says OR. You want even number or blue, so go ahead, you try out even number or blue. Alright, so here's what I came up with. We have 6 even numbers, 2, 4, 6, 8, 10, and 12. We have 6 blue numbers, 1, 3, 9, 10, 11, and 12. And then we have 2 numbers that we have to subtract out because we counted the 10 and the 12 twice, one in the evens, one in the blues. So 6 plus 6 is 12, minus 2 is 10, reduces down to 5 over 6. Alright, here we go. Now we have a new problem. We have a red number cube and a blue number cube. Find the probability of the red being a 3 and, right, keyword here, and, versus the other ones were OR. OR means we're going to add the possibilities. Now when we have and, we have to think independent or dependent events, but it's going to be multiplication. Since I roll a red die and a blue die, they're independent of each other. Their outcomes are. So we would find out the probability of a red 3. Well, there's one red 3 out of a possible of 6. And there are how many even numbers? 2, 4, 6. So that's 3 out of 6. And then you could reduce the fraction earlier, multiply out. 1 times 3 is 3. 6 times 6 is 36. Reduce it down. We get 1 over 12. Alright, moving down to the second problem, we want to find the probability we get a red 5 and a blue 1 or 2. So we go through, since it has the word and, we are going to multiply. Well, there's one red 5, so it's 1 out of 6, times, well, there's a 1 and a 2 out of 6. Top times top is 2, bottom times bottom is 36, reduces down to 1 over 18. Then we go down to the third one. We want to find the probability at red and blue prime number. Well, the probability that we roll the red die and anything comes up is 6 out of 6 times a prime number. Well, prime numbers, again, are numbers that are divisible by 1 in itself, and we say 2, 3, and 5 are prime numbers, so that's 3 out of 6 or 1/2. So really we're doing 1 times 1/2, which is 1/2. Alright, we're going to introduce here a new concept. If you look down at the second problem, it says this H little prime thing. That means not, or the opposite. So in this problem, we're talking about hitting balls. So the dad's pitching the ball, and the kid's going to hit the ball. When you see the this little symbol up here, that little slash mark, that means what's the probability of that? It's not going to be a hit. So we go through. Hayden hits 70% of the balls. Crosby hits 35% of the balls. We want to find out the probability that Hayden and Crosby will get a hit. Well, the probability Hayden is 0.70, and Crosby's is 35%, which is 0.35, and then we would take and multiply those two probabilities together, which is 0.245. Second problem is saying what's the probability Crosby gets hit? Well, that's 35% again. And then we want to find out he gets a hit and Hayden does not get a hit. Well, Hayden gets a hit 70% of the time. That means 30% of the time he won't get a hit. You take and find out what we get and multiply those two numbers together, and we get 0.105. You go ahead and try the second one, so pause the video quick and try the third one. So probability of Crosby getting a hit, again, is 35%. This little symbol means not, so the probability Crosby is not going to get hit is the remaining 65% of the time. Multiply those together, and you get 0.2275 or 22.75%. Alright, so in these problems we have the same type of philosophy because it's saying the word and down here. So we're still going to multiply, but there's one little thing that's different. If we pick a sock out of a drawer, that's one less sock than when we pick the second one out, what we have left. So when it's asking us for pink and red, in this case, this would be a dependent scenario because we have that idea of one less thing being in there. So when it says pink, there's 12 pink out of 30. And then red now, there are still 6 red socks. But our problem is there's only 29. So what I would do is, before multiplying, especially when you get some of these bigger numbers or when we talk with cards, I would reduce the fractions down. 6 over 29 is still good. 12 over 30 reduces down to 2 over 5. And then when you do your math, you get 12 over 145, and that should be fully reduced because we fully reduced it down before we multiplied. Alright, so let's try the last two here. What's the probability it's white and white? Well, there were 8 white out of 30, and then we took 1 white out, so there's 7 out of 29 left over. Again, I would try to reduce down. 8 over 30, they're both divisible by 2, so we would have 4 over 15 times 7 over 29, and then you get 28 for 4 times 7. 15 times 29 gives us a grand total of 435. Whoops. And then now we'll go down to multicolored and not multicolored. So thinking about it, there are 4 multicolored socks, so we have 4 out of 30.